We're going to do one that's easy. That's just going to be a representation of a swimming pool, just like this for concept or show existing conditions. And then we'll also dive into a resource on how to make a swimming pool just like this, using the layers involved, all the correct construction methods in case you wanted to detail out something like that. All right, stick around and let's go for a dip. A new file, we'll go to the Massing and Site tab. And with TopoSolid, we'll be doing Create from Sketch. Now this is going to be our boundary of it. Let's just go and make a rectangle. And then the actual thickness of it, I think by default, it'll do 1 foot thick. Go to edit type. You can go and edit the structure, turn to whatever material you want and thickness that you want. Now, if we want to go and carve out room for a swimming pool, right? We don't want to be swimming in grass here. We can go and click on this and go to edit sketch and just carve out what you want to carve out. So here's what that would look like. I'm just going to go and do a real skinny one just to show you what happens. So that's going to carve all the way through. And we don't necessarily want that. We could create another TopoSolid, infill it, join the geometry together. It's another way to go about it. Or what we could do is we could go to Massing and Site again, in place mass. Okay. Let's make sure that we set our work plane on the top. Go ahead and sketch that size out that you want. Once you're happy with the size of the swimming pool and the shape of it or whatever, say create form, void form. And this void form, we can set our depth to it. So let's just say maybe I want it to be 6 feet instead. So I'm going to do that. Before we say finish mass, we are going to hover, hit tab, pick it. We're going to do a cut command. So under cut, no, cut with, then cut from. Thank you for the preview. So we're going to do cut, cut. Now it's cut out. And what I like about this approach is you can like loft shapes together for different crazy void forms. So it doesn't have to be just a rectangle. Whereas this one has to be a rectangle and it's going to cut all the way through. So I think that's the better approach. Let me say finish mass. It has no solid geometry. That's fine. So now with this, I'm going to click on this floor, edit sketch, and let's get rid of this one that doesn't really make sense. Delete that one out. Let's develop this one further. So once again, we're going to be doing this in a fast conceptual approach. Adding on this topography, we could do like a split face sort of command, subdivide, they call it. And let's do pick lines here. Pick all that. And what if we just did a circle? We could do something like this. And that would create a pool deck for us. Or we could be deleting that out and just using the floor tool. Floor. We can go and create a floor for this. So let's go and find concrete. And we can do concrete with compacted gravel, 6-inch, 6-inch. Let's go do that. I'm hitting tab with pick lines to grab that quickly. They're going to overlap. So then this is where we might want to think about our height of our topography in relation to our finished floor elevation line. So maybe what we want to do is just a negative 6-inch offset here on the topography. Okay, let's start by making a concrete wall around our pool. So let's go 12 inches thick. It's not going to eventually be 12 inches of concrete, but for now, that's fine. We'll do pick lines. We'll start it at the pool deck height. We'll go to a depth of 6 inches thicker than we want our pool to be. We're going to do a finished face exterior, and we're going to hover, hit tab until we get it. And then we can hit tab and grab those walls and hit spacebar to bring them on the inside here of that loop if it doesn't generate that automatically. Now let's go to floor. And with floor, we'll do 6 inches of concrete, 6 inches of compact gravel. Let's hover on pick walls, hover on the inside, hit tab, grab everything. And then let's send that down to a pool floor elevation. And if you didn't make one, basically in the elevation view, just make a copy of your elevation and go down, name it pool floor. Make that the depth that you want the pool to end up being. So then now let's go back over here and check that off. It's going to ask us, do we want to like join some things together and all that. Let's just say no for now. We'll have more control over that later. So here you can see that the walls form the boundary of the pool. That's what we want. We want the top of the wall here where we end up adding this little coping, nosing, cap over the wall. We want that to become this sort of trim around our pool. So we'll let that pop up so that way later we can develop it that way. So let's go to structure and then let's go to our wall footing. Hover, hit tab again, and click on the walls. So basically now that's going to add a footing down there for us. So you can see it. You can go to site presentation, under view, you can create a section. And then in that section, here's what we've done. We have our earth here. We have our pool deck up here. We have our walls here. We have our pool floor, and then we have our footing. And here you see that there's a collision between two things. We have our gravel for our actual pool floor interfering with the footing. And we really don't need that compacted gravel in the way of the footing. I would do something like that to just represent how this is truly interacting here with the ground. Let's model the water. So we'll go to architecture, component, model in place. We're just going to call it a generic model and say, okay, let's call this water. Do an extrusion, pick lines. Oh, set the work plane. And we'll do pick a plane. Let's pick the bottom of the pool. Show it. Then we'll do pick lines and we'll just pick the pool boundary. That should be good. The extrusion start is at 0. That's where it's hosted. And then how tall we want that water to be. So why don't we make that like 4 foot, 6 inches tall for now. Say apply, check it off. There's our pool. Oh, it's not water yet. Let's click it. And then before we finish the model, the material, instead of by category, let's change that to be water. Edit the water. Use render appearance. Finish. Okay, so now that's how it looks in shaded, but let's go to realistic. Okay, so that's our pool. Okay, let's go and build this in Revit. This is an insulated concrete form, which Build Block makes, and this is their guide on how to go about the construction and engineering on creating a pool. This is awesome if you plan on heating a pool. So I really like the system here. In Revit, let's go and make that. So I already went ahead and started adjusting the layers here, but let's go and take a look at that together. So if you click on it and go to edit, you're going to see that the 6 inch is pretty good. 8 if you have seismic areas, and also if you have deeper pools. There's an engineering guide on their website for that. Then for the outermost side, the exterior, we're going to call that the side that's closest to the earth. We're going to do a waterproofing membrane. So basically just choose vapor retarder is fine. Do that 0 inches thick. We're going to change these forms to be thermal air. And then towards the interior side, that's where we are going to insert our base coat as a substrate. And that's going to be 1/8 inch, 0.125. And then we're also going to have our finish and just say, okay, an 1/8 inch. Now, here's the thing. We can specify what product we want for that. So to be a little bit more specific, we go here and we right click and we duplicate material and assets. We can go and name this thing Cider Proof FFPR. That's a brand name. Cider Power Base ICF with fiberglass mesh embedded. The finished wall texture, we'll do the same thing. We're going to right click, duplicate material and assets. Then this is going to be Cider Proof FFPR, apply and OK. We need to remember these because we're going to make those also part of the floor composition. Editing this and editing the structure. At ends, the interior, going to lap. So that way it's finished the same way on top. For the floor, let's go and click on that. Edit type. Edit. We are going to add below the structure, we're going to insert down before the core boundary, insulation And let's make that about 4 inches. And then above that, we're going to have a substrate of our site or power base. And then above that, finish 1, finish coat. These are going to be 1/8 inch thick. There we go. Okay. Yeah, it's going to start to overlap now because we added some thickness to it. And we might want to make this. Whoops, I forgot to make a copy of it. All right, so now with the pool, let's check it out in section. Where this laps, the footing shows past this. So to show this correctly, we have to go to View, Cut Profile, to cut this profile. Typical rebar spacing is going to be about 12 inch on center, maybe number 4 rebar. If you have a 5 foot max wall height, there's a literature on BuildBlock's website. So this is BuildBlock's technical installation manual. You'll see that they cover a lot here, every phase of construction. So this is a really handy one. There's also literature on their products and their sizes. Here's a good image of the ties that embed into the foam forms. And then this allows your fingers for rebar. Here's an example of the product specifications. So you've got everything from the concrete volume, surface area, R value, everything about it, which is really handy. And then this manual looks similar, but this is their engineering manual. And this would tell you more about the size of the footing, the size of the wall. If you're in a seismic zone, what do you need? It's a good piece of literature. This one I would definitely consult and also probably talk to a structural engineer just to be sure, especially if you're doing something crazy. There's a couple other resources that I found that I thought were really helpful in understanding the construction of pools. So there's a insulated concrete form builder magazine, and this just shows some cool during construction and after construction, utilizing the foam insulated forms. So basically this is concrete formwork that stays, right? And the ties in between the foam blocks to create this sort of sandwich panel with concrete in the middle, those also create rebar, basically ties. You would glue these blocks together to create a little bit stronger and tighter bond here, and also to help stop that concrete from pouring out in between it. But what's really nice about these insulated concrete forms, as illustrated here, you can have an above ground hot tub and it can help really retain the heat on both the walls and the floors. As always, there's a building code involved. So International Building Code has some specifics listed out for pools, and this is specifically Florida's building code based on the International Building Code that I'm looking at. Terminology, dimensions, signage, where different slope changes are, depth changes within the pool. So there's just a lot to know about if you're going to actually go and design a pool. So just be aware that all of this code exists. In our model, we're not going to go crazy on it. We're more so concerned about the composition of the floor, of the wall, of the profile for the coping, the fillet between the wall and the floor. So we're doing some basic stuff. But just realize that there's all kinds of code and regulation behind this. Now, I did skim this and took some notes on it. So everything that we do will be related to this code and just on a basic level. BuildBlock also put together a really nice phase of construction photo shoot here. Here's formwork going in after excavation for the footings. Here's the footing formwork with rebar. Here's the footings poured, and here you can see that some ties are put in to connect the footing to the slab that's going to be poured for the bottom of the pool, with the vertical rebar starting to get placed in. And there we go. More shots of that. Second row in. Gravel, compacted gravel placed. Rough in for some mechanical. Concrete being poured in. Walls and floor at the same time here. Steps going down in. Little cutouts that ties the floor into the wall. So it's connected to the footing and to the wall. Mechanicals in. ties being placed for the cap. Tile work done. Tile work done. Here they have foam used as getting the radius for the bottom for the wall to floor transition. That can also be done with the base coat or the finish system. And where you have cutaways for mechanicals, you'd fill that in with foam, spray foam. Cut it and sand it. Base coat going in and finish coat. Let's go make this in Revit. Okay, let's do the coping profile on the top of this wall. It's really not too bad. Revit, you used to have to go in, edit type, show section, do all this crazy stuff. It's actually getting better now. So if we go to architecture and wall, we can go and do a wall sweep. But in order to do the sweep correctly, we have to load in a profile that will work. So we actually have to create it ourselves. It's not a problem. We're going to go to new and we're going to go to family. And then we're going to go and choose profile and say open. Now I have one that I already made, so I'm going to close this one out. But essentially it's not that bad. It's just a profile that looks like this. 3.5 inches down, 1.25 inches out, and then just make a circle and trim it when it's tangent this line here. All right, now with this, I'm going to say load into project and close. And so in the 3D environment, here we are. I'm going to go down for wall. We're going to go to sweep. We want a horizontal sweep. The default is going to be the cornice, which is like a square cornice. You're then going to pick that square cornice and go to edit type. So if you were to like click on it, see that cornice. You would go to edit type. You would say duplicate. Okay. And then you would go and load in the profile that you just made. So in our case, it's the stegma profile. Now in our case, I already have it loaded. So there it is. It's not at the right height right now. I want my offset to be how tall I made it beyond that. Now, if I would have made my profile, if we go back to it here, I would have made it below this line. Then I can make it have 0 offset. If I keep it like that, say load into project and close. Actually, hold on, let me save it real quick. Load into project and close. Okay. Override existing version and parameter values. Here it is. I could just say there's 0 offset. And now comes in exactly at the height we want. So let's add or remove some more walls to the sweep. It is. And sometimes there we go, glitches. So there's our coping profile on the pool. Looks good. Section, here's our little cope. Now the coping itself, in the edit type of it, you can also pick the same material that you used for your wall finish. Well, pool, so it matches. Okay, so to do the fillet, we're going to go to File, New, Family, go to Profile once again, say Open. If we make it above this line this time, this will allow us to host it on the pool floor, and then we'll have our fillet kind of right up on that. So that's what we want. So then we're going to go to File, Save As, Family, and let's just name this Fillet Profile. All right, now usually the max fillet radius for a pool that I've been reading is 2.5 feet. So we want to be at least under that. I don't know. You can find out what your product or code requires. So anyways, we're going to go to Create, go to Line, snap it to that intersection there. And let's just go to the max of 2.5 feet. Excuse me. And let's grab this here, SI, to snap to the intersection, going up 2.5 feet. All right, now that we have those two, let's go and do the align command and lock those on these spots. So there we go. let's set the work plan to pool floor. And then we're going to go to sweep, horizontal. We need to make a edit type on this wall sweep, duplicate. We're going to call this pool fillet or cool fillet, whatever you want to call it. Profile for wall, material. Nice. Okay. Apply. Okay. And then if we click on that, let's make it a 0. I think, oh, okay. I see. And then we want to just change this to pool. Despite my best efforts to make that a parametric radius, this thing is fixed on the profile. So you would just go and make new versions of each profile if you wanted a different radius. All right, let's go and take a look at a section of this. Let's go and do a call out. Display level would be fine. All right, we're going to do this call out just like this. In the call out, it's not going to copy the hatch. It's going to Control C and copy that. Let's go to the call out. Change our scale. Let's hide the topo solid. And then let's go and paste the topography that we had copied. And let's make this a little bit bigger. All right. Now from here, we need to edit this to notch around how it's supposed to. It's under View, Cut Profile, do the bottom first. Annotate, filled region. Go to hidden line here. And I like to turn all the section lines to be thin lines. All right, so we have our water. Leave it like that for now. And we'll do a region, edit type, duplicate water. let's add some annotations to this. So I'm going to go to text. All right, I cleaned a few things up, adding in some additional lines, messing with where things are positioned, that kind of stuff. I'm ready to continue to go through the rest of this detail. All right, and then there would be a lot of rebar work in here, and that's something that you'd want to consult an engineer or potentially a manual on that. Once again, the manual is out there. BuildBlock has an engineering manual. This is actually it. And real quick, let's just throw in some detail lines. So I'm going to go over and annotate detail line to make the plastic brackets that are embedded into the foam forms. Just something simple to illustrate it. And I'm going to just copy that down. Okay, that's it. That's how to do a pool in Revit 2 different ways. One way fast, the other way longer. The longer way is more legitimate. Make sure to save, subscribe, and if you'd like the file, find it on my website at studiohero.co. All right, I'll see you next time.